EdXL, GCSE, Mathematics Linear, Paper 1, Non-Calculator Tier, June 2010. Again, as always, I would write down on the formula page anything you think you are going to struggle to remember throughout the exam. For example, it may well be that the external angles of any polygon total 360 degrees, and therefore to find each external angle you need to do 360 divided by n, and that gives you each external angle. Anything you think you're going to forget during the exam, make sure you write it down nice and early, and then you won't have to remember it. In question 1, I'm given a bar chart about the number of cows, sheep, horses and chickens on a farm, and in part A, I'm asked to write down the number of horses on the farm. So I can see the number of horses on the farm is given by this bar here. So reading off from the scale, that would be 6. In part B, I'm asked to write down the number of sheep on the farm. Sheep would be this bar here, so it's slightly more complicated, and it's in between these two numbers, but using the scale, I can see that that's 11. And finally, in part C, I'm told that there are 7 goats on the farm, and I'm asked to complete that on the bar chart. And I'm given the location of goat here, so I need a bar going up to 7. Obviously, you would do this with a ruler. Halfway between 6 and 8, that would be 7. In question number 2, part A, I'm told to write the number 15,672 in figures. So that is 15,672, and I'm asked to do it in figures. Part B, I'm asked to write the number 3020 in words. So that would be 3020. Part C, I'm asked to round 8,196 to the nearest hundred. So the hundreds near to that would be 8,100 and 8,200. That number 8,196 is roughly there, and therefore I can see that it's closer to 8,200. And in part D, I'm asked to write down the value of the 6 in the number 236,894. Well, I can see that this 6 here is in the thousands column. And I need to make sure, therefore, that I combine those two pieces of information and write down that that is worth 6,000. I can't just use the 1,000. I need to make sure I have this 6 as well. Question 3a, I'm shown the line PQ and I'm asked to measure the length in centimetres. So using this ruler, I can see that that is in between 6 and 7 centimetres. Now I've got to be accurate, so that is 6.5 centimetres. Important that you make sure that your ruler has got centimetres marked on it. If I use the other side of the ruler, it's got millimetres marked on it, and it has asked for the answer in centimetres here. The units are on, so I don't have to worry anymore about that. Part B, I'm asked to measure the size of the angle X. So again, using a protractor, place my protractor so the crosshair there is on the point of the angle, and I'm going to measure around. Now the temptation here is just to read the outside number, which is round about 145 according to this protractor. Now obviously looking at this angle, I can see that it's less than a right angle, which is 90 degrees, and therefore that can't be the right angle, so that definitely isn't the right answer. However, I did have the protractor in the right place. I just need to make sure that I use the correct numbers. So therefore I need to use the numbers starting from 0, which in this instance are on the inside of the protractor. So 0, 10, 20, 30, and then halfway between 30 and 40. I'm not sure I can come to the outside marks here. I can see that that is 35 degrees. And in part C, I'm asked what type of angle X is. And as it's less than 90 degrees, that makes it an acute angle. On question 4, I'm asked to write some numbers in order of size, and I'm told to start with the smallest number. So looking at the list, I can see that the smallest number is -6, and I'll cross that out as I go along. Then I've got -3, -2, 1, and then 7. In part B, I'm told to write some decimal numbers in order of size, and again I'm told to start with the smallest number. So what I'm going to do is I'm going to line these up in the place value table, and I'm going to start with 0.06. First number, and then 0.35, taking care to line them up. 0.63, 0.3, and 0.56. Now there's a couple of ways to do this. Some people would then add in an extra 0 here to make sure that all of those numbers have the same number of numbers after the decimal point. Some people would look at the column here, the tenths column, and see which number was the biggest there or which number was the smallest is what I'm after. And either way I can tell that this one here, 0.06, that's the smallest number. It's got 0 tenths, therefore it must be the smallest. After that I've got two numbers with 3 tenths, this one here and this one here. So I'm going to have to look at the number after that in the hundredths, and I can see that this one has 0 hundredths, and therefore it must be the next smallest number. That's that one done. And then obviously this one must be the one after that. Now I'll go back to my tenths column again, which is this one here. We've got 5 tenths as opposed to this one with 6 tenths. So 0.56. And that leaves me with finally 0.63. Now I was able to look straight at the tenths there because there was nothing in the units column. Obviously I would have had to look at that if the units were different. In question number 5, I'm told that Kunal goes to a cafe and he can choose one drink and one snack. And I'm given the drinks in this list here and the snacks in this list here, and he can only choose one from each. And I'm asked to write down all the possible combinations, and I'm given one here which is MA. So they've used M for milk and they've used A for apple. So continuing that logic, I'm going to use J for juice, W for water, S for sandwich, and B for biscuit. So they started with milk and apple, so I'm going to continue that. I'm going to go milk and sandwich. And then I'm going to go milk and biscuit. And at that point, I've exhausted all the opportunities with milk as a drink, so then I can move on to juice. So then I'm going to try juice and apple, and then juice and sandwich, and then juice and biscuit. And again, I followed a pattern where I've gone juice, apple, juice, sandwich, juice, biscuit, and I know I've dealt with all the ones with juice. It just takes me to finish off for all the ones for water, same pattern, water and apple, water and sandwich, and water and biscuit. Question 6, I'm shown some patterns made from sticks, and in part A, I'm just asked to draw pattern number 4. So I can see that from pattern number 1 to pattern number 2, I just added on 2 more sticks there. And similarly from pattern 2 to pattern 3, I added on 2 more sticks there. So it's just a case of carrying that on. So pattern 3 looks like this. And for pattern 4, I've just got to add on a couple more here. So I just need to add on those 2 bits there. And that's pattern 4. In part B, I'm told to complete the table. I'm given the pattern number and the number of sticks. Well, I can see in pattern 1 there's 3 sticks, pattern 2 there's 5 sticks, and therefore, as above, I'm adding 2 on each time. So I'm going to add on 2 each time to get the next one. So that's going to be 7 add 2 is 9, 9 add 2 is 11. I'm then asked to work out how many sticks from pattern number 12. A couple of options here. I can keep going from pattern 1 all the way up to pattern 12, and that's perfectly fine. So pattern 6 will be there, and that's going to be the number of sticks underneath for pattern 7, pattern 8, pattern 9, pattern 10, 11, and 12. And if I keep adding 2 on, I'm going to get 13, 15, 17, 19, 21, 23, and 25. So my answer is going to be 25 sticks. Now some people here might want to work out the nth term and say it's going up in 2s, so it must be something to do with my 2 times table. And if I write my 2 times table next to these numbers, I can see that I've got to add 1 onto them to get to the number of sticks. So it's the 2 times table plus 1. And then I'm simply substituting in the number n equals 12. And if I put n equals 12 in here, I'm going to get 2 times 12 plus 1, and that again is going to give me 25. Either of those is fine. In part D, I'm told that Ben wants to find the number of sticks in pattern number 100, and I'm asked to write down a method he could use. Well, I've already done this method up here. He could find the nth term. And I could show that I knew that that was 2n plus 1, and substitute in 100. It's also acceptable to actually work that out for them and say, okay, that will be 2 times 100 plus 1, 201 sticks. In question 7, I'm given a list with 8 numbers on, and in part I, I'm just asked to find an odd number. So any of those odd numbers would do. So the first one would be 7. After that, I've got 21. Either of those is fine. In part 2, I'm asked to write down a multiple of 5. Well, a multiple of 5 is something in the 5 times table. So 5, 10, 15. So 10 is in there. 15, 20 is in there. Again, either of those two will do. Part 3, I'm asked to write down a square number. So a square number is, for instance, 1 times 1, which is 1, 2 times 2, which is 4, and so on. So 4 is in there, that'll do. I've also got 16, which is 4 times 4, and that's my lot. And in part 4, I'm asked to write down a factor of 42. Now, a factor of 42 is any number that divides into 42, so 1 times 42. Both 1 and 42 are factors of 42. Similarly, 2 times 21, 3 times by 14, and 6 times by 7. So any of those would do, so any of those that are in that list. Well, 7's in the list. And I've also got 21 in the list. Either of those two numbers will do. In question number 8, I'm shown a rectangle, and in part A, I'm asked to find the area of the shaded rectangle. And I'm told to state the units of my answer. So before I do anything else, I know that areas are centimetres squared. Okay, so the area is the amount of space inside a shape, so all I've got to do is count these. So 1, 2, 3, 4, 5, and I can keep counting 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and it makes sense to write on so you don't lose any as you count it. So 15 centimetres squared. I'm going to get a mark for the 15 and a mark for the centimetres squared. Part B, I'm asked to find the perimeter of the shaded rectangle. Now the perimeter is the distance around the outside, so I've got to count all the way around the outside. Now I'm counting these lines, not the squares. So 1, 2, 3, 4, 5 here. This doesn't count. There isn't a line here, so this is just 6, 7, 8 using these 3 lines, and then 9, 10, 11, 12, 13 for that line there, and then similarly 14, 15, 16. Notice I'm just counting the lines, not the squares. So therefore the perimeter is 16, and they've already given me the centimetres. In question number 9, I'm shown a table with information about boxes of cereal, including how much they cost and the weight of one box. And in part A, I'm just asked how much does a box of Frosties cost? Well, Frosties is here, and I can see the cost of that is here, which is £1.55. In part B, I'm told a box of cereal has a weight of 375 grams, and I'm asked to work out which one that is. So 375 is here, so that must be cornflakes. Part C, I'm told a box of cereal has a weight of 600 grams and costs less than £2.50. So there are 2 of these that have a weight of 600 grams, which is this one here and this one here. But I know that it costs less than £2.50. This one is more than £2.50, so it can't be that one, so it must be this one here. And I'm going to write down the name of this cereal, not the cost, the name. So I need to write down Rice Krispies. Make sure you answer the question. And in part D, it says Ed buys 1 box of Cocoa Pops and 2 boxes of Shreddies. So we've got 2 boxes of Shreddies. And I'm asked how much money in total does he spend. So 1 box of Cocoa Pops would cost £2.79. And each box of Shreddies is going to cost £1.85. And I've got to remember there's 2 of those, which is why I put 2 ticks up here. And I'm just going to add those up. So 5 add 5 is 10, add 9 is 19, 8 add 8 is 16, add 7 is 23, plus this one is 24. Decimal point goes in, and 1 add 1 is 2, plus another 2 is 4, plus this 2 is 6. So altogether he spent £6.49. They've already put the symbol for pounds in there. On question number 10, I'm given a coordinate grid, and in part A, I'm just asked to write down the coordinates of the point P. So I go along the corridor and then up the stairs. So along the corridor and then up the stairs, and I've gone 2 across and 3 up. So 2 across and 3 up. So my coordinates 2 and 3. Part BI, I'm asked to plot the point 1, 2 on the grid and label it Q. So again, along the corridor 1, and I'm going up and down the stairs the 2. So along 1 and up 2. So that would be there, and I'm told to label it Q. So I need to make sure I put a cross on and label it Q. I don't want to see any circles or anything along those lines. It's got to be a cross and the letter Q. And in part BII, I'm asked to label the point -3, -2 on the grid and label it R. So -3 means along the corridor -3 there, and then down the stairs -2 there. So that distance is -3 and -2 in terms of the grid. Okay, so I want to cross on there and label that R. In question number 11, I'm shown 9 cards that James has, and in part I, I'm told that he takes a card at random, and I'm asked to write down which shape is most likely to be on the card. Well, if I want to summarise this, I could just maybe do some sort of tally. So I've got circles, I've got squares, and I've got triangles. And whilst you might not want to do this, it will make sure that you don't make any simple mistakes. So 1, 2, 3 circles, 1, 2, 3, 4, 5 squares, and 1 triangle. Now that should add up to the 9 cards I've got, and it does, so I know I haven't missed anything. So the shape most likely to be on the card is a square. And then I'm asked in part 2, what's the probability, which means a fraction, because it hasn't asked for it in words, that James takes a card with a square on it. Well, I can see that there are 5 squares, and that's out of 9 cards in total. What we don't want to see is any words here like likely, because it asks for a probability, not a word. In question 12, I'm given the number of text messages sent by 7 people in one day, and I'm asked to find the mode. And the mode is the most common, so I'm looking for the number that appears the most often in this list. Well, I can see that there are 2 6s, and each other number appears only once, so the mode is 6. And then I have to work out the range, and that is the biggest value, take away the smallest value. So the biggest value in this list is 15. And I need to subtract from that the smallest value in the list, which is 4. So 15 take away 4 is 11. So my answer will be 11. You can see there's 2 marks here, and 1 mark is for showing you're working with a subtraction. And in 12 part C, I'm asked to find the median. And the median is the number in the middle. So the first thing I need to do is put those numbers in order, because the number in the middle doesn't mean anything unless they've been ordered. So I know the smallest number is 4 from the previous question, so I can cross that off. I'm then going to go to the next one, which is the 6s. So I've got 6 and then 6, they can both be crossed off. Then I've got an 8, then I've got a 9, then a 12, and then a 15. I've now got them in order, so now I can find the middle number. And to do that, I'm just going to work my way in again. Smallest one crossed off, biggest one crossed off. Next smallest, next biggest, next smallest, next biggest, and I'm left with this number here in the middle, and that is my median. So my median is 8. Question 13, there is a table showing the percentage of each type of book in a library. And in part A, I'm asked what type of book has the smallest percentage. So the smallest percentage there is 2%, but it's what type of book, so I need to make sure I write down science fiction. Again, making sure I answer the question. I don't want to find myself writing 2% because that doesn't answer the question. In part B, I'm asked to write 13% as a decimal. So 13% is 13 out of 100. Still as a fraction though, so I need to change that into a decimal, and that means 13 divided by 100. And if I do that, I'll get what it is as a decimal. Now, if you're not sure, you can use place value table and write 13, and the decimal point would be there. Divide that by 100, and I'd end up with 0.13. Part C, I'm asked to write 24% as a fraction. So as before, 24% is 24 out of 100. And I'm then told to give my answer in its simplest form here. So I'm going to try and cancel this down by dividing the top and the bottom by the same number. So both of these are even numbers, so that will go down to 12 over 50 because I've divided it by 2. Again, they're both even numbers, so I'm going to divide them by 2 again, so 6 over 25. And then I'm going to keep trying again. Can I divide this by 2? Yes, I can, but I can't divide this by 2 either. So I've got to then try the other numbers. So can I divide both of them by 3, 4, 5, and so on? None of them will divide, so my answer is going to be in its simplest form, 6 over 25. Part D, I'm told there are 3,000 books in the library, and I'm asked to work out 15% of 3,000. So I'm not allowed a calculator, so the first thing I'm going to do is I'm going to find 10% of 3,000. So to find 10% of 3,000, I need to do 3,000 split into 10 equal parts, because 10 lots of 10% would give me 100%. So 3,000 divided by 10 is 300. Now if I want 15%, I also need another 5%. So 5% of 3,000, well, if I already know what 10% is, 5% would just be half of my 10%. So that's going to be the 10%, which was 300, divided by 2. And 300 divided by 2 is 150. So if I want 15%, I can add 10 and 5 to get 15. So I can add 300 and 150 to get 450. So 15% is equal to 450. In question 14, Tanaka says that when you multiply an odd number and an even number together, you will always get an odd number. And I'm asked to show that Tanaka is wrong. So all I'm asked to do is try a few things and make sure that I can show that I'm going to get an even number. So pick an odd number, for example 3, multiply it by an even number, which is 2. 3 times 2 is 6. Therefore this one here is even. I've shown that she's wrong. In question 15, part A, I'm given a diagram and I'm asked to write down the value of x. Now I can see that these two angles here are what's known as vertically opposite angles. And when angles are vertically opposite like that, they are the same value. So x will be 38 degrees. And in part A, part 2, I'm asked to give a reason for this answer. And the reason would be that vertically opposite angles are equal. I need to make sure that I use the word vertically, not just opposite angles. In part B, I'm shown a diagram and I'm told to work out the value of y, and y is this angle here. So the first thing I have to do is look at my diagram and see if I recognise anything that I can use. Now I see these two lines here mean that these two distances, p to t and p to q, are the same length, and that creates me an isosceles triangle, which is p, t, q. And that means that this angle here and this angle here are the same size, and that will help me later on. So the first thing I need to work out is this angle here. And I can see that that angle there is going to be 180, take away 110, which is 70 degrees. And the reason for that, which it's going to ask me later on, is that the angles on a straight line add up to 180. Okay, so I now know that this is 70 degrees. Well, from what I said previously, I can say that this angle and this angle are the same size. So I need to be able to tell them that, so I'm going to label the angles properly. So here I worked out PQT, so I'm going to call that angle PQT. And now I'm going to say that PQT is equal to PTQ, and that's because angles at the base of a isosceles triangle are the same. And I'll get away with just writing isosceles triangle, two angles are the same, or two angles are equal. Okay, so I'm now saying that this is 70 as well. And from that I can work out that the angle y, or TPQ, is equal to 180, take away 2 lots of 70. 2 lots of 70 is going to be 140. 180 take 140 is going to be 40 degrees. And again, the reason for that is that there are 180 degrees in a triangle. Now in part 2 it does ask to give reasons for your answer. I've given these reasons as I went along here. So as long as you show you're working, you'll be okay for part 2 as well as part 1. In question 16, part A, I'm asked to simplify P, add P, add P, add P, and that is just 4P. And in part B, I'm told to simplify M times M times M, and that is M cubed. It's important that I make the distinction between M cubed and M3. This 3 has got to be up in the air, not the same size. Part C, I'm told that B equals 2K plus 12, and then that K equals 5, and I have to work out a value for B. So B is going to be equal to 2 lots of K. K is 5, so I want 2 lots of 5. I'm going to add on 12, so 2 times 5 is 10. I need to add on 12, and that'll work out for me what B is. And that's obviously going to be 22. Part D, I'm told that T equals 4W take away 2, but this time I'm told that T equals 22, so I'm going to substitute that value of T in there. So 22 equals 4 lots of W take away 2. And I've now got an equation I need to solve. So the first thing I'm going to do is I'm going to get rid of this take away 2, because I just want to know what 4W is, not 4W take away 2. So I'm going to add 2 to this side. And to make sure it balances, I'm going to add 2 to this side as well. So 22 add 2 is 24. This side, with 2 added on, would just become 4W. Now, I don't want 4 lots of W, I just want 1 lot of W, so I'm going to divide by 4. I'm going to have to again do that to both sides. And this side divided by 4 would give me W, and this side divided by 4 would give me 6. So W is 6. Question 17, I'm given a quadrilateral and asked to write down the name of it, and that is a kite. In part B, I'm asked to show how that shape tessellates, and I'm told to draw at least 6. So I've got a kite here. Now, I would normally advise you do this with tracing paper and just moving the shape around, but I can see that I can fit one in there, but that's only 2, so I now need to fit some more in. Now if I turn that shape upside down, I can fit one in there, and then one in there, and then one in there. Now, I know it's a tessellation because there are no gaps, but at the moment it does say to draw at least 6 shapes, so I need to put one more on, so I'm going to stick one on this side. And now make sure I've got 6 shapes. So 1, 2, 3, 4, 5, 6. You can obviously draw them anywhere on the grid. You could have another row underneath rather than ones further over. But the important thing is that I haven't got any gaps between those shapes. That's what a tessellation is. In question 18, I'm told that Leslie goes to the cinema and the film starts at 18:10 and lasts for 135 minutes. And I'm asked to work out what time does the film finish. So I'm going to draw a little timeline. So there's 18:10, and I've got to add on to that 135 minutes. So I know there are 60 minutes in an hour. So if I add on 50 minutes to this, that's going to get me to 1900. So I'm adding on 50 minutes there. Okay, if I add on another 60 minutes, that would take me to 2000 hours. And so far I've added on 110. Well, I've got another 25 left to add on. That was the original 135, so that would be 2025. So the film finishes at 2025. In part B, I'm told that there are 300 people in the cinema and that 1/6 of them are boys. So I need to work out 1/6 of 300. So to find a sixth of something, I'm going to split it into 6 equal pieces. So I'm going to share it out between 6 people. So 300 divided by 6 is 50. I'm then told that 3/10 of the 300 people are girls. So 3/10 of 300. So what I'm going to do is I'm going to work out what 1/10 is. So 1/10 of 300, same as before, I'm dividing it between 10 people. So 300 divided by 10 will be 30. And want to know what 1/10 is, I can work out 3/10 by saying that it is 3 lots of that 1/10. And 3 times 30 is 90. So I've got these two numbers here, one for the number of boys, and this one for the number of girls. Okay, I'm told the rest of the people are adults, and asked to work out how many are adults. So if I add the number of boys and girls, which is 90, add 50, I'm going to get that there are 140 children in there. And therefore, to work out the number of adults, I'm going to do 300, take away that 140. 0 take 0 is nothing. I can't take this 4 away from this 0, so I'm going to have to borrow. That 2. 10 take 4 is 6. 2 take 1 is 1. 160. Now, when you do any subtraction in your test, it's worth just checking it by adding those two numbers back up again. 140 and 160. And if I've done it properly, I should get the number I started with, 300. So I've obviously got that right. So my answer is 160 adults. In question 19, I'm given a distance time graph for a journey, and in part A I'm asked what time did Nigel leave home. So from reading the original information at the top of the page here, I'm told that he left home here. So this here is halfway between 10 and 10:20, so that would be 10:10. And in part B I'm asked how far was Nigel from home at 10:20. So at 10:20, which is here, I need to draw a line using a ruler in the exam up to my graph and then read off accurately what it is. Now this is 10 and this is 20, and I can see if I go up in ones 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 that the scale works. So this must be 13, and the units are already on of kilometres. Part C, I'm asked how many minutes did Nigel spend at his friend's house. And when he's at his friend's house, he is going to be the same distance from home, so he's not moving, so he's stationary with this part of the graph here. Means he's not moving. So we need to work out how long he was there. So coming down from here, you can see that he arrived there at 10:40, and that he left there and started moving again at 11:10. So it's just a case of working out the distance from there to there in terms of minutes, and I can see that that is 30 minutes. So he's at his friend's house for 30 minutes. Question 20, part A, I'm asked to work out 2/3 times 1/5. And I know that when I multiply fractions, I simply multiply the numerators and multiply the denominators. So 2 times 1 is 2, 3 times 5 is 15. In part B, I'm asked to work out 1/7 add 2/21. Now I can't add them at this moment in time because they've got different denominators. So what I'm going to do is I'm going to create a set of an equivalent fraction chains with the 1 times table on the top and the 7 times table on the bottom. And similarly for 2/21s, I have the 2 times table on the top and the 21 times table on the bottom. Now I'm not going to go any further because I can see from that straight away I now have two fractions where the denominator of 21 is the same. So rather than using 1/7, I'm going to use 3/21s, and I can actually use 2/21s as it was originally given to me. So if I add those two fractions, I'm going to have 3 add 2, which would be 5/21s. Notice it's not 5/42. Okay, that's the wrong answer. I'm adding fractions, so I just need to keep this denominator the same as 21. In question 21, I'm given the weight in grams of 16 eggs, and I'm asked to draw a stem and leaf diagram, and they've been very specific about me needing to include a key. So I'm going to do that first because it will get me a mark. So I'm going to take the first number, 47, and I'm going to say that 4 and then a line and 7 means 47. Okay, there's a bit of space here, and that's to do an unordered stem and leaf diagram. So I'm going to copy the diagram from underneath, and I'm going to say that I've got the smallest number looking through here. I've got some in the 40s, some in the 50s, and some in the 60s. So the smallest number must be one of the ones in the 40s, and it looks to me like it's 43 here. That's the minimum number. May not be, but that's what it looks like. Similarly, looking for the maximum number, I can see I've got some in the 60s, so it looks like this is the maximum number. And therefore, the smallest part of my stem will be 4, and the largest part will be 6. And then I'm going to go through adding them on here as I cross them off. So 47, 45, 50, 53. Trying to line the numbers underneath each other. 43, 61, 53, 62, 58, 56, 57, 47, 55, 62, 58, and 58 again. Now, it's tempting for some people to try and put this into order straight away. I would always advise you do it unordered here, which is what this is. This is unordered, and that means that the numbers in the leaves, 7, 5, 3, and 7, are not yet in numerical order. Underneath, I'm now going to put them in order. So again, 4, 5, and 6. This time I'm going to start with 3, 5, 7, 7. And then here I can see that 0 is definitely still the smallest. 2 3s. That was correct, but now I need this 5 to go here. I then need this 6, and then the 7, and then the 3 8s. And then in the bottom row, I have the 1, 2, and the 2 in the right order. The last thing you should do is just check. In the question I was told there was 16 eggs. Have I still got 16? So covering up the stem, I've got 1, 2, 3, 4 here. 1, 2, 3, 4, 5, 6, 7, 8, 9 here. And 3 here. And as long as that adds up to 16, I haven't lost any. So 4 and 9 is 13, plus 3 is 16. In question 22, I'm given a triangle T on a coordinate grid, and I'm asked to rotate it 180 degrees, about the point 10. So I'm going to mark 10 on. They've already done it for me. It's just there. Now, it doesn't give me a direction because I'm going 180 degrees, but normally, if it was anything other than 180 degrees, you'd have a direction, either anti-clockwise or clockwise. And it's important that you go the right way, this one being clockwise, and this one being anti-clockwise. So I'm going to take a piece of tracing paper, and I'm going to trace the shape onto it. And I'm going to put my pen on the point where I'm told to rotate it now 180 degrees. I need to make sure I go through that angle, so I'm going to draw an arrow facing up, and I know that this will be facing directly towards me when I've gone through 180 degrees. So at that point, the shape is rotated 180 degrees. Now I can see the 3 corners are here. Just a case now, transferring those onto my paper, and then making sure that I can put that back on there and it's the right size, and it is. So I'm going to take that off, join it up with a ruler in the exam, and I'll get that shape there. Question 23. I'm given 2 shapes, P and Q, and I'm asked to describe the single transformation which moves P onto Q. So there are 4 transformations. There is a translation, which is a movement, which obviously isn't this because the shape has changed size. There's a reflection, and again I can rule that one out. There is a rotation, and the shape is spun round, and that isn't it. So that leaves me with the last one, which is an enlargement. So there are 3 marks for this question, so I'm going to get 1 if I write down enlargement. That's the transformation. I then need to give some information about that enlargement, and I'm going to need the scale factor, how much bigger it's got, and I'm going to need the center of enlargement. Okay, so the easiest thing to do here is to join up corresponding points, so that point in there and that point in there, they correspond to each other, and draw through there a straight line, and do that for another couple of points on the shapes, Q and P. And if I do that, I can see they meet here at 1, 0, and that is the center of my enlargement. So the center is 1, 0, and that's another mark. Now the next bit is to work out the scale factor. Well, in the shape P, this side here is 2 squares, and this side here is 4 squares. So these distances have been doubled from P to Q, and therefore the scale factor is 2. In question 24, I'm told that Anil wants to find out how many DVDs people buy and I'm showing a question that you use, which is how many DVDs do you buy? And then there are some boxes underneath for people to answer. Now I'm asked to write down two different things that are wrong with this question. Now usually with these it's that there is no time frame, and there's no difference here. It hasn't asked how many DVDs they buy in a week or a month, it's just how many do you buy. So there is no time frame in the question. And that's a fairly standard answer for these types of questions. And similarly again, what else is wrong with it? Well, these response boxes here, if I actually bought 5 DVDs, I could tick this one or that one, so the boxes overlap. So the response boxes overlap. You could also have that there isn't a box for 21 or more. There isn't a box for if they don't buy DVDs. Any of those would suffice. In question 25, I'm told that Anna and Bill share £40 in the ratio of 2 to 3. So Anna and Bill, so Anna and Bill, and Anna gets 2, Bill gets 3, and therefore in total it would get 5. Now we've told they've got £40, so I've got to carry on until I get to £40. So if I double Anna's times by 2, she gets 4, Bill gets 6, and that would mean they had 10. If I carry on this pattern, Anna would go from £2 to £4 to £6. Similarly 3, 6, 9, and they'd have 15 in total. So this could be a times table problem. I could just work my way down, all the way down here until I got to the correct number, and I want to have £40 here. Now that's the long way of doing it. The other way of doing it is to say, okay, I know I need to get from 5 to 40. How is that going to happen? Well, it's going to be some multiplier. And to work out what I'm multiplying by, I can do 40 divided by 5, and that'll tell me how many 5s go into 40, and that is 8. So I need to multiply by 8. And then it's a case of multiplying both of these numbers by 8. So 2 times 8 would be 16, and 3 times 8 would be 24. And 16 add 24 does still come to 24. So Anna gets £16 and Bill gets £24. I could, of course, just have kept going here, and I'd gone 2, 4, 6, and I'd had 8, 10, 12, 14, 16. That would have been Anna's. Bill's, again, 3, 6, 9, and he would have then gone to 12, 15, 18, 21, 24. I've got the same answer. Either way is acceptable. In question 26, I'm asked to work out the volume of the triangular prism. Now the keyword here is prism, and the formula given at the front of the book tells me that the volume of any triangular prism, or any other prism for that matter, is dependent on the area of the cross section at the front here. And then I can multiply that by the distance backwards, the height or the length, depending on how you want to consider it. So all I need to do is find the area of this triangle on the end. So the area of the triangle is the base times the height divided by 2. The base is 4 centimeters, the height's 3 centimeters. I need to divide that by 2. So 4 times 3 is 12. 12 divided by 2 is 6 centimeters squared. And that's squared because it's an area still, it's two-dimensional. Okay, so I want the volume of the prism. I'm going to take the area of this cross section, 6 centimeters squared, and I'm going to times it by the height, which is 20 centimeters. So 6 times by 20 is 120, and that will be centimeters cubed. Centimeters squared times centimeters is centimeters cubed. They've already given me the units here, so I'm just having to write down 120. On question 27, I'm asked to work out 4.52 times 36. Now, a variety of ways to do this. What I'm going to do is I'm going to work out 452 times by 36. And then I'm going to realise that that answer is going to be larger than what I need. And specifically, it's going to be 100 times larger because I've multiplied 4.52 by 100 to get 452. So I'm going to have to divide my answer by 100. Okay, to do 452, I'm going to set up a grid. So 452. I need to multiply that by 30 and 6. So then, drawing a grid, 2 30s are 60, 30 times 50 is, well, 3 5s are 15 and a couple of zeros to add on, 1,500. 3 times by 4 is 12, and I've got 1, 2, 3 zeros. Back to this row here, 2 times 6 is 12, 6 times 5 is 30, and I've got to add this 0 on, so 300. 6 times 4 is 24, and I've got 1, 2 zeros to add on. Now it's just a case of adding all those numbers up. So I have got 12,000, 2,400, 1,500, 300, 60, and 12. Notice I've just lined up this column here, the units column. So that's going to be 2, 7, 9 and 3 is 12. Carry the 1 over into this column, which is 5, plus the 1 is 6, and this one will be 1. So that's the answer to this part of the question. So I've got 16,272 divided by 100. And if I divide that by 100 using the place value table, if necessary, so 16272, and the decimal point will be in there after the units column. Divide it by 100, it gets shifted twice in this direction. So I'm going to have 162.72. So 162.72. Now, there are other methods for this. Some people would use the Chinese grid method. Very similarly, you're going to end up with 4, 5, 2 along the top, 3 and 6 down here, and diagonal lines drawn in. So 2 3s are 6, 3 5s are 15, 3 4s are 12, 2 6s are 12, 6 5s are 30, 6 4s are 24. And then working your way around, you're going to get the same number. So 2, a 7, 2 carrying the 1 over, 6 and a 1. So you get exactly the same numbers, and if you put the decimal point in where the point would be between 4 and 5, it then slides down and meets up with the decimal point from the 36, and you end up with the same answer. So the decimal point of 36 will be here, so those two would come down vertically here, and this one will go across horizontally, and they meet here, which means they come out between the 2 and the 7, just as we had here. 162.72. Question 28. I'm told to factorise 3x plus 12. So a factor is a number that divides into something, so I need to find the number that divides into both 3x and 12. So factors of 3 are 1 times 3. Factors of 12 are 1 times 12, 2 times 6, and 3 times 4. And I can see that the only repeated factor is 3 here in the 3 times 4, and the 3 in the 1 times 3 here. So rather than writing 3x, I can write 1 times 3 using this pair times by x. And I'm adding on to that 12, which I'm going to use 3 times 4 instead. And that means that I can take this 3 outside my brackets because it appears in both terms and everything else is different. So I've got 1x here. I need to add 4. Now when I write my answer, I'm going to get rid of that 1, so it's going to be 3 lots of x plus 4. And if you factorised anything, you should be in a position to then check it by multiplying it out. So 3 lots of x will be 3x, which is what I wanted there. 3 lots of 4 is 12, and that's positive 12 that I wanted there, so I know I've got the right answer. In part B, I'm told to solve 4 lots of 2x minus 3, which is equal to 5x plus 7. So the first thing I'm going to do is I'm going to expand this bracket. So 4 lots of 2x minus 3. So 4 lots of 2x is 8x. 4 lots of take away 3 would be same as taking away 12. So using that for the left hand side, I'm going to have 8x take away 12 equals 5x plus 7. Okay, working through there, trying to cancel down and get what x is on its own. First thing I'm going to do is I'm going to take away 5x from both sides. And I know I can do that because I've got 5x on this side and enough x on here to do 5 subtracted away from it. So 5x taken away from there would be 3x. Still take away 12. This has been taken away. I've still got add 7 or just 7. Okay, now I'm trying to get x on its own, so I'm going to try and get rid of this term. Is take away 12, and to do that I'm going to add 12 to both sides. And so I'm going to end up with just 3x here. And on this side I'm going to do 7 add 12. Important, I've got to add 12 to both sides, and that's going to be 19. Okay, so now I want to get rid of just this 3, and I'm done. So I'm going to divide by 3. So that will leave me with just x on this side, and on this side I've got 19 divided by 3. Now 3 doesn't go into 19 a whole number of times, so I'm going to use a fraction and I'm going to write 19 divided by 3, and that's perfectly fine. And finally, in 28 part C, I'm asked to expand these two brackets here, so I'm going to draw a box. Same method I use for multiplying numbers, and on the first bracket I've got y add 4, and the second one I've got y add 5. So y times y is y squared. Y times 5 is going to be 5y, and that's add 5y. Y times 4 is 4y, and that's add 4y. And 4 times 5 is 20. And a positive times by positive is a positive. So I have got y squared plus 5y plus 4y plus 20. Now the two terms in the middle here will simplify. So adding 5y and adding 4y is the same as adding 9y. I've still got y squared, and I've still got add 20. So my final answer is y squared, add 9y, add 20. And that concludes the exam paper.